If you want to learn programming and become a programmer, and maybe you're a bit confused by all the conflicting advice out there, then you should watch this video now, because I'm going to show you how a common myth is holding you back and how easy it can be to get started. In this video, I'm going to show you the only 8 concepts that matter when it comes to programming. These are the building blocks upon which everything else is built, and interestingly, this has nothing to do with what programming language you use or what editor you do your coding in or anything else that might have tripped you up in the past. In this video, I'm going to give you the big picture, the 30,000 feet view of these 8 concepts, and if you want to take a deeper dive, you can go to choosethelanguage.com and get access to training that takes you much deeper into these concepts. I know I've interrupted what you're doing right now, I know you're busy, so I'm just going to give you the big picture right now. But if you like what you're watching and you want to go deeper, just register for the training at choosethelanguage.com. It's only $27 and you'll love it, and if for some weird reason you actually don't love it, there's a money back guarantee there. Now, as I said, if you boil programming down to its very core, there are only 8 concepts. Not 8,000, not 800, 8 concepts. And while it's true that programming takes time to master, it's not true that there's simply too much to learn or that you need to know everything before you can create useful software. That's a myth, it's a lie, and we'll crush that lie right now. There are 8 basic concepts, and when you understand these 8 concepts, you'll be able to pick up any programming language, which is great because a software developer today is often required to juggle at least 2 or 3 languages to create anything that's actually useful in the real world. So if that freaks you out right now, don't let it. The concepts are the same, the words you use in the different languages are mostly the same, and the way you put those concepts and words together, the same. It's all the same, it's just different flavors, really. And just knowing that little secret, if you take that little piece of knowledge to heart today, then you'll have a great advantage over those who've only ever learned one language and who think learning another one will be too difficult. Now you know better. In fact, people who are so-called full stack developers, that's people who know just not one language but 2 or 3 or 4 languages that make up modern software. They are highly sought after because they're a team of developers all by themselves in one person. And the foundation of all that is knowing these 8 basic concepts. So let's have a brief look at all of them. Let's arm you with some knowledge so you'll be able to learn any programming language a lot quicker. Remember, this is the 30,000 feet view, so I'll go a bit quickly here. Before we delve into each one, I'll show you what they're called. They're called output, input, functions, variables, conditions, loops, arrays, and branches. Do you think you could learn 8 concepts? I think you can. So let's dive right in and see what we have to play with, really, because this is our playground. So the first concept is output. It's what comes out of your program. If nothing came out, your program would be a black hole. It wouldn't display anything on the screen. It wouldn't really do anything. Or if it actually did something, we wouldn't know because it kept it as a secret to itself, so that wouldn't be very useful. It would be just use energy and it wouldn't be much fun at all. So we need the program to put something out into the world. For example, a web page for a user to read, or it can send an email, or it could buy a stock. So that's output. It's what comes out of the program. Our second concept is input. Now, we have a program that puts things out into the world, but if the program never gets any input, it can only act upon things you as the programmer put in there to begin with. And a program like that would probably be very boring. So imagine a calculator but the user couldn't type any numbers into it, or Facebook but nobody could post anything, oh my god, or a stock buying program that could only buy one particular stock that you hard coded in there. Now, to be able to output anything interesting, our program is going to need some input to work on as well, usually from the user or something it reads from the internet. So it could be what numbers to add in a calculator, what pictures to upload to make our friends love us even more, or what stock to buy when the time is right. So our third concept is functions, and you can think of a function as a machine. A function is the machine that takes the inputs and turns it into the output. For example, a cow is a function where the input is grass and the output is milk. And a calculator is a function, a machine, where the input is some numbers and some operator like plus or minus, and the output is another number. A stock picking function could look at the markets and the weather, for example, and decide what stock to buy right now. Now the fourth concept is variables. A variable is a named value. If you're going to create a machine that adds two numbers, for example, you could call the numbers A and B. That's the names of the values. And then you could add A to B. And A and B would be variables. They're called variables because, well, they vary. And once you finish adding 3 to 4, for example, you might want to add two other numbers. So you just put those other numbers into A and B and then ask the machine to add those. And that way you don't have to create one machine for every possible combination of numbers you want to add, like one machine to add 1 and 1, and one machine to add 1 and 2, and one machine to add 1 and 3, and so on. That's not fun. And programming is about playing and having fun. So instead you can create a machine that adds A and B, adds A to B, just one machine, and then you can vary what A and B actually means. So that's a lot more satisfying. In our stock buying program, the variables can hold what stock to buy next and the maximum price we're willing to give, for example. So the fifth concept is conditions. You're used to using conditions in your everyday life. We often start our conditions with the word if. If you're hungry, then eat. If you want to learn programming, then start with the 8 concepts. If this stock is cheap enough, buy it. Conditions say if something, then something. They are the basis of what makes a computer program smart, in quotes. Its ability to make choices based on the input. The sixth concept is loops, and a loop is exactly what it sounds like. It's something that happens multiple times. This is what computers are great at, which people are not, to do tedious tasks over and over again, maybe with slight variations. So that's why we have loops, so that instead of having to tell the computer 1,000 times to do something, we can tell it to do something 1,000 times. That's a lot easier for us. Just say, do this 1,000 times. It's more fun. And the seventh concept is arrays. Do you remember variables? We talked about them several seconds ago. A variable is a named value. An array is a collection of such variables. Instead of calling it a collection, we can simply call it a list. Now, if you have a list of variables and you ask the computer to loop through the entire list and do something to each element in the list, then you can start to see we are creating something useful. For each person in this list, send them an email and remind them to be happy today. So in that scenario, the email is our output, just to go back to that concept of output, okay? Or for each stock in this list, check if the price is right to buy. So lists are useful. We call them arrays, same thing, really. Eighth and final concept is branching. Now, normally a computer program is run by the computer in the order it is written. Just like you read a book from top to bottom, the computer reads your program from top to bottom, and it performs the commands you've written in the order you've written them. But sometimes, however, it's useful to tell the computer to go somewhere else in the program. For example, if you've created two functions, one to add numbers and one to subtract numbers, and your user presses the plus button, then it's really useful to ask the computer to go to the function that adds numbers and not to the one that subtracts numbers, so we don't completely surprise our user or simply lead them astray if they're not paying attention to what they're doing and they simply trust the answer we give them. Or if your stock picking software finds that the time is ripe for buying a particular stock, it could call out to the buying function to actually perform the transaction. So there you go. Those are the 8 concepts. Not that hard, really. Everything else in programming is built upon those 8 concepts. You master these and you understand any programming language. Now, I hope you enjoyed this and found it helpful. And again, if you want to take a deeper dive and really get these core concepts and see better examples of them, then please click the link or simply go to choosethelanguage.com. On that page, you'll find a letter that tells you a little bit about my story, and it offers you a book and some videos that will go deeper into all of these concepts. And if you really want to go deep and learn how to become a full stack developer, I'm offering a special preview edition of a new course I'm creating to people who buy the book, and only to those people. So you'll see that offer if and when you buy the book. Anyway, I really hope you enjoy this and that it helps you, no matter if you click onto the next page or not. And I really enjoyed creating this training for you. So I hope to see you soon. Take care. Bye-bye.